Good morning.
Good morning.
Everybody.
Good
Uh,
morning. Good morning, Professor.
I'm uh, I'm Frank Pena, and I'll be your instructor this semester. If you're not supposed to be in energy trading systems, then welcome anyway. Would you turn off your videos if you don't mind? Just keep your videos and your mics turned off. It works a lot better. And I will go ahead and start the class for the spring of 2021. You're in the energy trading systems. It's a focus on natural gas industry, and it's part of the Bowers College of Business at the University of Texas. And what we'll do this morning is we'll have an introduction class, and then we'll dive into the details of the industry. And I wanted to just discuss a few things with you, and we'll go over the syllabus and get some of the administrative work out of the way. But we will be studying in the energy sector natural gas, and I say that because in one of my previous classes it was like the third class, and the student thought we were teaching them about gasoline that you put in your car, as opposed to the natural gas that cooks your food or warms your house or generates electricity. But we'll get more in depth into the actual sector that energy source is and what we study. The important thing about it is that all energy sources have a very similar path as far as the flow of the transactions, how it's handled, and how it gets to the consumer, so that what we learn in this class is really applicable to any energy source, as well as to other types of industries, because it all starts with supply and demand, and it has a transactional chain, and everything that we'll discuss is applicable to building an iPhone, to delivering food to a store. It's the same concept because it's a value chain, and we'll be discussing that in those terms. Just wanted to give you a little background as to why I teach the class. And like I said, I've been doing this on Saturdays since 2009, when we had 16 students in the first class. And I have a regular job, a full-time job, and I'll get into that. I'm president of a company. I'm a managing director of another company. And throughout my career and in my education, I had a lot of wonderful people that, took the time to share with me their knowledge. And I learned a lot from them. And it's been that knowledge that I acquired from all those kind people that allowed me to build the career and the successes that I've had in my career. So that's what I'd like to do. And that's why I teach the class. I want to give a little bit back to the wonderful industry and the educational system that provided me the opportunities. I started teaching the class because I have a concept that I call an asset from day one. And in being an asset from day one, to give you a little background, when I was at the large energy companies, pipeline companies, trading companies, where I first learned about the natural gas industry, I had to recruit, not had to, but part of my function was to recruit new students. And I wasn't particularly keen on that, not because the students weren't very knowledgeable. They were very eager. They had degrees and they were ready to go. But the problem is that it took like about 9 months to a year, or sometimes if they were really good, 6 months. So you'd be 6, 9 months, or maybe even a year before they became productive members of the team. And the reason why is the natural gas industry and the industry sector of energy per se has a lot of lingo. It has a lot of language. It has a lot of concepts, flows of information, linkages between transactions and so forth. So until we were able to bring them up to speed on all of this energy sector language and explanation, so we had to start from ground one. So instead of being an asset, the new recruits really were a bit of a drag on the department because we had to teach them from the ground up. And I thought, well, wouldn't it be wonderful if students just came out of the industry with a wonderful finance degree or IT degree or whatever discipline they studied, and knew the language and knew how the industry worked and knew how it all functioned, they would be an asset from day one. And that's where the term came. And our goal is, and it has been our goal for the last 10 years, is to take college students that have a strong background in accounting and in engineering, in finance, economics, IT, supply chain, and make them an asset from day one by providing them the terminology, an in-depth understanding of how the energy sector, in particular natural gas, works. And that's the goal for this year as well. We've had a lot of success stories coming out of our class, coupled with their other education. I'm saying that it's a package deal. It's kind of like you have to have your accounting and your engineering and your economics, IT training, but couple that with an understanding of the industry, and it just puts you ahead of all other recruits that are going for the same positions you are, because the industry will acknowledge your understanding. And it's not a difficult course. I mean, I normally ask, the students when we used to have, on campus classes, how many of you are taking this class because you heard it was easy? I was surprised by the number of hands, because I would get, when they have the evaluations of professors, the students would say, yeah, the class is easy. Well, I'm here to tell you that if I gave you a test today, I doubt that, unless you've been in the industry or you are from the industry, and even if you are, that if I gave you a broad test across the spectrum of what we'll be teaching this year, the majority of you would fail. So that's not to say that you're not smart, but you can't be tested on something you don't know, right? So by the end of the course, the predominant number of students will make A's. And is that because the class is easy, or because you learned about what we're conveying to you, you see? And the answer is, yeah, it's because you learned. And that's why you can make the A, because nobody would make an A today. So having said that, let me go over a few of the ground rules in here. We are an online class, so attendance isn't mandatory. I think that it's good for as many of you to be here, because we have, and I didn't mention it, but we have quite a few people online as well that will be helping with the class. And there's several ITs. There's Mohammed Usama. Are you here, Usama?
Yes, I'm here.
And we have Amanda Flowers. Amanda, you here?
Yes.
Okay. There are a couple of people from Rise. Rise is a company that I'm a part of, and that provide us with the trading system that we'll be using throughout the course to learn how to trade gas, schedule it, store it, account for it. It's a really almost an accounting transactional system that we have the honor to use, and it's provided by the Rise Solutions Company. Jonathan Pena, are you online? We might have not gotten here yet, but we had a couple of people from Rise that'll be joining. But Amanda and Mohammed will be our TAs this year, and we will go ahead. Fifi also, Mosby will be joining us from time to time. So we actually have 4 people to help. The class is extremely large this year. We had the largest class that we've had so far was 252. We're up to over 285 this year. So that is really, really great news. Glad to have everybody on board. The class, like I said, is easy because we teach it in a way that it really is a weekly discussion. I wish that when I came into the industry, I learned my understanding of the industry every day at work, right? I wish I had an opportunity to sit down with somebody that had done all these things, that I've had the opportunity to do, and just have a discussion with them. and just say, how does that work? And how did you do that? And how was that developed? And where did that come from? And why do we do it that way? You know, those are the questions because, you know, be truthful with you. There's a difference between instructional knowledge and applicable knowledge. And I say that because instructional knowledge is the information that you obtain and you know, and you can recite it back, but applicable knowledge is knowledge that you can use to solve problems or to actually do your work. And I've met both. I've met 4.0 students from Baylor that really had a tremendous resume, but had no applicable knowledge. They didn't know how to use the education that they had in their job. And that's what you really need to have is applicable knowledge. You know, grades are important, but I've been in the industry for over close to 40 years. I don't know that anybody keeps their job because they have a great grade point average. You get the interview because you have the grade point average, but it's the knowledge that you have that's going to keep you and make you successful in your career. So if you took tests and you knew it for the test, but when you go to your job, that's gone and you forgot what you learned, then you really didn't learn it, so that it's not going to help you in your career. So when people take tests, it's good because it tests what you've learned. But if you really learned it, you'll remember it 5 years from now. And that's the knowledge you want to obtain. And that's what we're going to try to do in this course, is we're going to give you an opportunity each week to acquire applicable knowledge, knowledge that you can take to your workplace if you're not already there. But when you get a job here in the near future, you'll be able to use that knowledge to advance your career. Along the way, what I'll do is I'll be telling you stories. And I had one student a couple of years in the evaluation of professors said, to the extent, you know, it was an okay class, but I think the professor told too many stories that weren't applicable to the course. And I kind of felt sad and bad, you know, sorry that that student had missed it. Any story that I tell you applies to something that we're working with, right? So it's something that I learned. It's a story about what happened, and look for the meaning of the story. I'm not just telling stories just to entertain us. They have a meaning behind it. I'll tell you that knowledge is around us all the time. So you want to pay attention, and it's free, because normally you people that are very knowledgeable are around you. You want to pay attention and see how they do things, how they say things, how they think, because that makes you even stronger in your knowledge, right? I early in my career, when I was a manager of a department that was doing processing plants, I needed a technology student, a technology person. So there was somebody that we were working with, and I made him a deal, and I said to him, "Can you know, you want to go ahead and work for under, you know, our department for 6 months while you build that system, and I'll teach you about the natural gas, and maybe you can teach me about the technology, how to do programming, and we'll exchange knowledge." So what happened is that for 6 months, I took him with me to every meeting. I took him with me to every planning session. I took him with me to every you know, conference I had in Washington or Atlanta. He traveled with me. He was in every session that I was in, and then we would meet, and he would teach me about technology, and that's how I got to developing systems. And I'll talk to you about that in a little bit. But at the end of the 6 months, it was like incredible, because I asked him. I said, "Well, you know, how did it work out? What do you think? Did you learn a lot?" And he says, "Well, I think it worked out okay for you," he said, "because I taught you about technology, but you never took the time to teach me about the industry." He had sat in all those meetings. He had gone to all those planning sessions, and he hadn't learned anything, because his method of learning was to sit in a classroom and there'd be an instructor up front, and that's the only way he knew how to learn, I guess. But learning is around you all the time. Information is around you. And that's how I learned. I learned from watching other people, seeing how they solve problems, and they then would provide me that knowledge, and I would obtain that knowledge and then use it from there forward. So what we want to do is every week we want to have these meetings. We want to have discussions. I'm going to tell you about, show you about the industry. And throughout the sessions, what I'd like to do, because normally in a classroom setting, we would raise our hand and I would call on you and you would ask your question. But in this platform that we're now in, it's kind of be difficult if we have, 200 plus students all trying to talk at the same time. So I've asked Amanda to go ahead and look at the chat. So if you have anything on chat that you would like to go ahead and ask, then go ahead and do that, right? And Amanda will stop us at the appropriate time and say, hey, look, we have a question. Let's go ahead, and I will respond to that question. If we don't have a non-answer, which is going to probably be unusual, but if we don't, we will go ahead and get you the answer, and we'll get back to you on that. So the protocol is you put your question on chat, and then you go ahead and we will answer your questions, okay? So moving on, what we will do also, the objective of this course is to provide you with real hands experience. There's a difference in sitting in the classroom and hearing about business, and there's a difference between you being given the opportunity to create a company, to load the information for that company, to enter trades, to schedule gas. The system we will be using is a system that's used every day. It's being used today by some of the major energy companies in the United States, if not around the world. We have customers the likes of Northern Illinois Gas in Chicago, Alliant in Madison, Wisconsin, Washington Gas and Light in Washington, D.C., Washington Gas Midstream, a huge marketer in the East Coast, Virginia Natural Gas, Atlanta Natural Gas. We got the Russian company, Gazprom, they're our customer. So that's just to mention a few. So the system that we have the privilege of using is a real system that's used to buy billions of dollars of gas and transport it across the country every day of the month, 365. So we'll be using that system. So you really will get hands-on experience. Imagine going to an interview and saying, yes, I've used a real ETRM, which is an energy system to trade gas, schedule gas, store gas. I've created invoices. I've done that. I doubt that any other student in the nation, if not around the world, can actually say that coming out of college, that they've used a real system to do all the transactions that are done on a daily basis, okay? So we have that to look forward to, right? And by having this hands-on, that's just going to improve your chances of success. And that's a goal here, because along the road of my career, a lot of great people gave me opportunities, and you got to work hard at it, but those opportunities, look for them because they're there. The other thing that we'll use is a concept that I call the flow concept. In everything that we do, there's a fluidity or a flow of transactions, a physical flow, a transactional flow, a procedural flow, a relationship of flows. And that's how you tie all these things together. And we'll be covering that. The other thing we do is we sectionalize. We create sections of the industry, and we follow those sections at a top-down level. In other words, I've never learned anything by actually starting in the weeds at the very detail, because it makes no sense. You're learning all these formulas, you're learning all these detailed transactions, these detailed movements, but at the end, because you haven't been shown what the ultimate high-level result or movement of that is, then it's harder to understand. So what we will do is I like to discuss it almost like at a mall. Okay, there's a difference between walking into the mall and just going to the left and start going down one side of the mall and then up the other side looking for your store, when you really could have gone to the kiosk in the middle and looked at the map and seen where you are and where the store is that you're looking for. So that's a lot easier on you. If we rise to the top, we see the big picture, and then we drop down in each section and learn the details after we've learned the higher concept. Okay, so we're going to talk about flow concept and sectionalized top to bottom approach. Let's get some administrative things out of the way. And I want to go ahead and apologize for the number of students that had to email us and let us know that the syllabus had wrong dates. And for all of those students that were really eager and jumped in there, whatever you pulled off of Blackboard prior to yesterday, don't use it, because that's not current year. What normally happens with Blackboard is they roll it over from fall of 2020 into this year, and normally it's wiped clean and it has all the courses together. And this year, when they rolled it over, it came with last year's information. Okay, so if you took anything, a syllabus or examples or PowerPoints, they're going to be different this year. So just put those away. And we will go ahead and every Friday, we'll try to do it early on Friday. We will put the relevant information for that week's course, right? So, or that class. And like I said, go ahead and we'll communicate through email and Blackboard, but always check your Blackboard for more information. And again, like I said, if you have an old syllabus, the new one is up there now and it has the correct dates and everything. You can go over the course objectives, which I think we've done a little bit, the fundamentals, the concepts of it. We also have a concept that we call the three functions, we call it the industry of threes, because it seems like they come in threes, right? There's three functional areas, three marketplaces, there's three processes, and we'll go into that as we go into this week's PowerPoint. But there's a lot of threes in here. So class information, you got it here. Let me tell you, this is really important, is that since we're offline and I work, so if you have a request to discuss something, we can arrange for that. But Saturdays is probably good. If you wanted to go ahead, we normally don't take the 3 hours because we have labs. So if you wanted to talk after the class, we can do an additional meeting and we can go in and we'll go ahead and set up and answer your questions or anything else that you want to discuss. But again, send all requests for help, for meetings, for anything to this email address right here. If you email me directly, the chances are that I won't respond as quickly as you'll get a response from this email, because I have so many other emails, business related, that they get mixed up and I prioritize them, and this is your best email. So do not email me directly. Email uh support@risesolutions.net. We don't have a textbook in this course. We will do it based on PowerPoints. There is a good book that if you were really wanting to know a little more of what I called earlier, the instructional knowledge, there's a really good book of understanding today's natural gas business, and you can get that online, but it's not required. It's just additional information that might help you with the class. We'll give you the ETRM system. It's called Gas Track, and we will be providing you that after the first 2 weeks. We normally, by then, the class has settled down because we don't want to set up a bunch of several companies that people are going to drop in the first 2 weeks, or we get new people that are coming in late, a little bit late. So we'll go ahead after 2 weeks. We'll give you the credentials. There's a whole video on how to log in and how to do everything to get your labs going. So policies on late submissions, you know, you really, really want to do things early, not late, whether it's here or on your job. Timeliness matters. Timeliness will reflect on your career path. If you're making people wait at meetings or you're not finishing your task on time, your career will suffer. In this class, your grade will suffer, right? So that if you turn in your work late without a legitimate excuse, if you're in the hospital or you had an operation, we want you to email us before the deadline. It's not good to email us like 3 days after the work was done. Oh, by the way, I'll be late, right? You need to do it before, whenever possible. So, and the way that we grade the course, and I'll get to that here in a minute, but I want to just explain how you can determine what your grade is at all times here in a few minutes. These are the relevant, important dates when you can drop the class. Of course, we're having our first day of class today. Here's exam 1. Here's the last day you can drop with a withdrawal, you know, and so those are the dates. Drop policy is right there. Course evaluation, this is up to you, but they do have a course evaluation that you might be familiar with, and where you can go ahead and just evaluate. I think it helps the university determine, you know, the instructor's performance or the professor's performance. So I would encourage you to fill in the evaluation. It helps the university. I don't want to say it doesn't matter to me, but, you know, I do what I do, and you take from it what you will, and we're good, right? So this is really important, especially in today's climate where we have the Respondus lockdown web browser. I know, because I develop technology, that's what I do for a living, that if you wanted to find a way around it, yeah, you could do that. You could get an A, but you'll probably fail when you go work somewhere and tell them that you know about energy, because you won't. And they'll know that. And so if you want to go down that path and suffer down when you actually get a job and you say that you knew or you took this class, you know, I've had several students that have come to me during the semester and said, I went to BP, I'm applying for a, you know, apprenticeship or temporary work, and they asked if I had taken your class. And they're asking, not because I talked to BP, although our customers do business with them, or Conoco. We got several companies that ask, you know, Sequent asked, have you taken this course? Because they've hired students from this course and from the university, and they like what they're getting. So they will ask you that. So make sure that you mention it during your interviews and learn the information. It'll impress them. So whenever you are dishonest and taking your exams, at the end, you're going to suffer for it, because the people that you work for will know that you didn't learn it. So again, we want you to be as honest as possible, right? Again, don't use lab results. You're not learning anything when you do some other people's work as yours. We have right here, and I'm sure that you already know about this, to accommodate students with special needs, and you can contact this number. I don't know if it's relevant in today's, other than testing, and we can work with you on that since we don't have in class, right? This class is all about learning. It impacts your grade, and the reason I say that, if you don't watch the video and you don't come to the sessions, it's going to impact your grade, okay? And just know that you got to do the work in order to make a good grade. Could somebody turn off your video, please? Check your video, make sure it's off. Okay. Let's talk about grades. The grades here right here are listed, and you get 40 points for your gas track system, and I'll show you right in here. These are the points just for logging in, getting all your access done, getting all the work done to log into the system is 3 points. Loading source information, 6 points. And these are points off your final grade. So everybody starts with 100. You have 100 for your grade today, okay? If you don't do this lab, you're down to 94 because there's 6 points off. If you don't do this lab, you're down to 88, okay? So labs are important. Make sure you deliver them on time, okay? And make sure that you test it. We even have, and we'll show you that in a subsequent class, a way to check your work before you finish it. It tells you if you got an error, it tells you where your error is so you can go correct it. We provide you videos on how to do them so that we give you every tool you need to be successful, right? Just get the work done early. We have a deadline, and deadlines are usually at the end of business day on Friday or on Saturday or whenever it is. And the last thing that we want to see is 200 people asking for help with 5 minutes left before the deadline, right? Because we're probably not going to help at that point. So you need to get your labs done early and submitted on time. So again, going back to the grades, there's 3 exams. They don't build on each other. We're going to have exam 1, 2, 3. They're 20 points each. There's a built-in curve on these exams because we have 22 questions per exam, but we only grade you on 20. So that if you had 2 missed questions or answers, 2 wrong answers, you still make your 20 points. So there are no curves other than that. So we don't want to hear, is there any way we can curve our grade? We already built it in. So you get a 10% curve on every test, right? And 40% on your labs. So there's your 100% for that. And we'll go down, and like I said, these labs, right now we're saying to be announced because as we're developing these, we will have these in the next week or so. So don't fret about these. We'll go ahead and get them to you and give you plenty of time. We always give you 2 weeks or 3 weeks to finish some of these. And they shouldn't take, if you understand, if you've been attending the class, if you watch the videos, I would say worst case scenario is maybe an hour, right? And most of them are like less than an hour. So there's no reason why you shouldn't be able to submit them on time. Your lab assignments or due dates are strictly adhered to. Late work will be penalized by partial or entire credit is penalized. So if you don't do it, and the other thing is you need to do it because if you don't do the first one, you won't be able to get in the system to do the second one. If you don't do the second one, you won't be able to trade because you didn't do the first one. So even if you lose all the points, you still have to do it if you want to make any of the points in the subsequent labs. So that's going to be really important that you do that. And then down here is a schedule. This in years is flexible. There may be weeks. We don't know what the future holds. We may have to move them, readjust them. We'll notify you, especially like when Harvey came in, we had to reschedule everything so that things can happen. Now, I don't think we'll have a hurricane in the spring, but things can happen where we may move a date back or forth. And again, since we're recording the videos, I don't think that it should be a big issue because of that. All right, let's see what we got here. So that should cover all the things on our syllabus that we needed to cover. And we'll go ahead and now start with the actual class. Amanda, do we have any questions?
We have one question.
Can you speak a little louder? Sorry.
Yes. One student is wanting to know whether the lab is also for graduate students.
Yes, it's for everybody.
And then I guess the last question is typically how long do you have for each exam or how long the exam typically takes?
You know, Mohammed, I think that if you studied and you paid attention and you knew you know what we're teaching. Some people finish it in 15 minutes, 30 minutes at tops. Mohammed with us?
Yeah, I think it should not take you longer than an hour to complete the exam.
Okay. But you can finish it in 30 minutes.
Yeah, you can finish it in like 10 minutes. Some people just do like 10 minutes and they get out. So it just depends on you. How prepared are you?
And I see one that's, we are recording these, so we will put them out there. Okay, let's start with the actual course.
Hey,
And
Frank,
yes,
there is one more question. Are we taking exam during the lockdown?
run that again.
The person is asking, are we taking exam during lockdown? Do we take the exam on lockdown? Yes, you do. It's going to be an online, so you
Okay.
don't have to physically be somewhere. It's just going to be online.
Okay. All right, so let's go to the first one. We already talked a little bit about why I think I can teach this class, is that we've been here since 2009, teaching a very similar course. It's evolved over the years. During the week, I manage RISE services since 2017. I formed the company that spawned RISE in 1993. I worked with many major pipelines and in energy companies before 1993. Probably managed most of the, if not all, the major gas departments because of the unique position that I held, and we'll go into that in a little bit. I got an associate degree from the Texas Southmost College. Now, of course, after I leave, they make it the University of Texas at Brownsville. So, go figure. Then now it's Pan American, UT of Brownsville. And I am a CPA, and I studied the classes in hydrocarbons, which is natural gas, up at the University of Oklahoma. In the 40 years I've been in the industry, I've worked with production, acquisition, processing, transport, accounting systems, technology, compliance solutions. Today, we're building analytics for our customers to look at their data, tell them where they're making money, tell them where they can avoid losing money, show them a high-level picture through graphics. So we're evolving into the analytics of letting the information tell stories, which is really a great experience. So I learned what I know from the energy giants that I worked with. When I came to Houston, I had a degree. I had a degree in accounting, of course. I went to all the big accounting firms. They weren't hiring, so I ended up taking a job with United Gas Pipeline, and the rest was history. Once I got into the energy sector, I didn't go back to the accounting, although our system does the accounting, and it was great that I understood the accounting because that's what our customers use the transactional system for. I've been an expert witness in front of the Federal Energy Regulatory Commission hearings in Washington, D.C. We will learn a lot about this four-letter word that starts with an F, FERC, F-E-R-C, is the commission that oversees pipelines and energy industry in general. I've also been an expert witness in company litigation on contract disputes, chairman of the Southern Gas Association twice. I guess I didn't do it well enough the first year, so they asked me to come back later, a few years later, and I'm a member of the AICPA. So that just gives you a little bit of the background. And these are just some of the systems that we've built over the years. When I worked for United Gas, we built Unite. When I worked for Northern Natural Gas, we built financial forecast model. We have an optimization model. We have Sea Robin pipeline. I've built several systems. Here's the one that you'll be using. We have an Energy Gas Pro system as well. And now we have Energy Flow, which is the trading system that has the graphical views on it. So it's interesting because this course, when we first started, it was a technology course, and they wanted us to teach technology or not teach technology, but to come in. And a lot of people over the years have said, well, this isn't about technology, or this isn't about finance, or this isn't about accounting or supply chain. No, it's about the real world where technology develops applications, where accounting accounts for the transaction, where finance does finance matters for the energy industry. And I don't know how you do financing for an energy company if you don't understand what that company does that you're helping finance, right? Or that you're helping account for. So the course itself is not particularly a technology or an accounting, it's all of them. It's how those disciplines work within that industry, okay? So why energy classes? Well, it has to be one of the top runaway industries. Energy is big, big, big business. We live in the energy capital of the world, which is Houston, Texas. Now, these right in here will be on your test. What is Houston, Texas called in the industry? It's the energy capital of the world. So throughout the lessons, I'll say, and you should remember this for your test, right? And you should remember that because it's on a question on your test. So you might want to take notes of what is there, right? It's highly regarded and abundant career opportunities, highly rewarding. They have some of the highest paying salaries of all industries. They continue to pay very, very high salaries, even when times are tough for all the other industries. And you don't want to go into something just because it pays a lot of money. But if you like accounting or you like finance or you really like something, then you're going to be good at it. But it doesn't hurt to be in an industry that rewards you on top of that, right? So it welcomes all degree plans, like I said. My first boss at United Gas Pipeline had a forestry degree. He was a forest major, and how to make trees grow, or manage trees. And he went into the industry, and he was my manager for a few years. Anyway, so why this energy class? Because we want to go be an asset from day one. We want to understand the industry as a whole, from physical assets, operations, business, management, controls, accounting, technology, settlement, right? It says, a famous person by the name of Albert once said, and I'm paraphrasing, if you can't explain it simply, then you simply don't understand it. If you're ever talking to somebody and they want to use the big words and they want to get complex on you and they want to get all, this is so difficult and it's so hard to explain, I wish I could explain it, then they probably don't know it. And that's why they're making it difficult. People that know it can make it simple. They will give you simple examples if they want to convey it, right? And Albert Einstein said the same thing. So as I was with a customer who said, Frank, the system looks so simple, I'm concerned that it can't do our complex transactions. And I responded, the system is as simple as you want it or as complex as you need it. And he bought the system. So that's exactly how we're going to look at it. We're going to look at it simple, and then we'll get to the complex. But by then, that too will be simple.
Hey, Frank,
Yes.
we have some questions about how the energy industry has been affected by the pandemic and how they're going to sustain jobs with upcoming EV and hydrogen cars.
Well, those are great questions, right? The pandemic, from our perspective, hasn't really impacted us because we work closely with some of the major energy companies like Washington Gas Light, take for example, or Northern Illinois Gas. They provide energy to generate electricity, to heat your homes. So pandemic or not, if anything, the use of home energy has increased, so demand has increased, because now instead of having all the people in one building conserving energy by being in the one building, you have thousands of homes that are consuming have computers, have refrigerator, everything is running at your home 24/7 now. So really the demand has gone up for the energy industry. And as far as hydrogen cars or electric vehicles, you know, sometimes I think, do we really understand that the energy industry is providing energy, right? And whether that energy comes from hydro, and I was just about to get to that next slide, it might help answer that, whether we are going ahead and using any of these renewable or EV, or we use any of the hydros, you know, it's still energy. So from this course, we'll still need to track the units. They're still going to bill you for the energy units. That's what we do. We track energy units regardless of its source. And there'll always be a need for people to create the invoices, to pay for the energy, to track the transport of that energy. Just because we're moving to cleaner energy doesn't eliminate the chain, the value chain. So that's one thing. Second of all, I get that a lot. You go like, when we have electric cars, okay, about 70% of the electricity is created with gas. So unless you figure out how to create all that electricity from something other than oil or gas, then you're still burning hot carbon to create the electricity that's going to run your car. So I don't know how we missed that in the discussion a lot. So again, I think renewable energy, new energy sources will come as technology improves. Right now, we could have green energy, but let's put it this way. We can have, I hear all the time, buy America. They go, buy America. And you go to Best Buy and an American TV is $1,200 and a foreign TV is $600. Then I don't hear buy American anymore, right? Because all of a sudden the dollar counts. So if we wanted to pay $6, $7 for gasoline or to power our cars, we could do that through cleaner energy. We could do it through corn and through different ways. But how many people are willing to pay the $6, $7 per gallon versus the $1.80 or the $2 you're paying today? So again, there's got to be the technology bringing better energy, but people willing to pay to live in a more carbon-less world, right? So it's a catch-22. I'm neither against nor for, carbon. I just teach what is there today, and when we go to clean energy, then I'll teach that. So I hope that answers your question. And like I said, even this right here, they call this the sun renewable. Well, no, they tell me in about 7 billion years, this is going to end too. So it's not renewable, but we call it that. Renewable for the near future, right? So the other ones all came from these same energy sources, but they got buried in the ground and became these energies here, right? So we'll go through that in a little bit, but you have renewable and non-renewable. And recently we got a lot more of this when we got fracking, and I'll explain that as well.
Thank you, Professor. That clarifies it all.
Thank you. The path of the industry, let's talk about that. And I don't know, this slide may be a little bit ahead. Let me go here to this slide here. Let's talk about this for a minute, okay? Let's talk about the business fundamental that we'll be talking about this industry, right? And let's take another example. Let's take an example of wheat, right? Or corn, or any type of farm product that's out in a field. There is no frosted flake boxes on a tree. You don't go out to a tree and pull the Tony the Tiger off the tree, right? It's not there yet, right? So you have to harvest the raw material. You got to take it and create supply. You got to transport it. Then you take it to a processing facility. Then you bake it, you put sugar on it, you box it, you package it, you make it market ready. and either you store it if you don't need it yet in big storage facilities, or you take it down to Kroger's or Randall's or Fiesta or wherever, and consumers buy it. But this is a trail of a supply chain. So you got raw material, you got aggregated supply, you got transport to the processing to make it ready for the market. You either store it and then take it to the market, or you take it directly to the market. And that's easy to understand to me. I look at it and I go like, okay, there's three moving parts: supply, logistics, and demand. That's all it takes: supply, logistics, and demand. Logistics has three parts, which are transport, processing, and storage. Don't forget this, because the whole concept of our class is based on what you're seeing here, and we'll cover that a little bit more. But these three are combined. They're in that rust color, right? Which is the logistics, the supply, and the demand. Unfortunately, most products, the supply isn't where the demand is. So you got to get it from the supply to the demand, either by by transporting it, processing, and sometimes storing it to get it there. So that's pretty simple to understand. Let's look at the complex world of natural gas. Oh, wow, not that complex. It's the same thing, isn't it? So we go like raw material, supply, transport, process it, make it market ready, store it, and deliver it to the marketplace. That's the course, the logistics part of those three: supply, demand, logistics, right? So that'll be on your test in several different forms. How many major functional areas are there? Three: supply, logistics, demand. How many, which of those three has three moving parts? Logistics, it has transport, processing, and storage. Okay. So now that we understand what we're going to be learning is how do they do this? How do they get it here? How do they do this? What happens in here? What happens over here? And what happens here? Both physically, operationally, transactionally, accounting, compliance, all of those things are going to be discussed throughout the course. And by the end, you will know not only the high level overview, but you will go ahead. Most people can earn a living just by knowing this, or knowing this, or this, or this, or this. Very few people understand this. And it's called silo employment. You are put here. So sometimes you come out of a college and they say, well, you're an accountant, we're going to put you in accounts payable, and your career is in accounts payable. Don't really understand the supply or how the transport works or how the processing works or how the storage or demand, how they hedge, how to buy cheap gas, how to transport it at a better price. They just do accounting. But then that's where you are, and all you know is just that one department. The industry is, it's hurt by not having where employees understand the full spectrum of everything. And we're developing courses for the corporations to take classes that bring this to their employees, but that's another story. So going back to where we were right here. Now that we discussed the three big major fundamental parts, let's talk about how they've changed over the years, right? So when gas first started, way before before there was any regulations and anything, I call it the Wild Wild West, right? Because little producers or really farmers, they would find that they was like very low level or up on the ground. They would see like bubbling brooks or whatever. That was the gas escaping because it came to the surface, and they would go ahead and cap it. And then they found out that you could burn that gas and you could sell it and you could make money as energy. So all the producers in every little area were doing their own little thing, right? But as they started growing, they started forming companies that did nothing but production, transportation. And as the industry grew, they had no regulation. They could do whatever they want. There was no safety involved. You know, there was no strict regulations on how you marketed it, what you could get for it. So in the 1930s and thereabouts, and of course, these are big numbers. It could be 1920, 1940, but on either side of this, government decided to regulate, okay? They overly so did it, and they regulated too much, and we'll go into that, right? But they told you how much you could make for what gas, depending on whether you got it onshore or offshore. And there was all sorts of regulations. When you over-regulate something, you stifle the industry. You don't give the industry the ability to be innovative. One of the biggest obstacles that I ran into when I first entered the industry in the mid 80s, which you see here, deregulation. That's when I came into the industry. They kind of deregulated it, but they kind of still regulated the pipelines. They unregulated the producers, the users, or the consumers, but the pipelines were kind of still regulated. But I'll tell you, so when you overregulate, what they found out is that they had an escalation of prices of what you could pay for gas. And every year they got an incremental price. So over the years, every year they made more and more and more money, and the consumers paid more and more and more. And the government finally said, well, you know what? If we continue this, gas is going to be $100 a unit by the time we get done. So maybe we're not doing this very well. So let's get out of the business and let the market forces run the natural gas and energy business. And that was a deregulation when I came in. But the pipelines were still heavily regulated. And by that, I mean, the pipelines back then made their profit based on a percentage, an annual percentage of their investment. So if they invested in a pipeline, $10 billion, they would make 15% of that every year. If they did a horrible job, they made 10%, 15%. If they did a great job, they made 15%. There was no incentive for the pipelines to be innovative, to develop new processes, because they were going to make the same money. I would go to them, and again, this is, firsthand knowledge I'm sharing. I would go to my bosses and I said, you know what? If we bought some computers, because back then Compaq had just released their first computers, and I taught myself how to write programs, and I would go to them and I said, if we could buy this and get a server, and I could do automation, we could do the invoices, we could do the nominations, and it would only cost this much. And they would say to me, Frank, that's all good and fine, but we're spending money and we're not going to make any more money anyway. So why do we care? Yeah, but we do pretty lousy job and our invoices are really late. Yeah, but we make the same. So why do anything, right? So that was this big giant dinosaur of an energy industry back in the 80s when I first came into the industry. And I was very frustrated by it because none of my ideas were being implemented because they didn't make any more money. They just saw it as a cost. Well, in 84 through 87, they deregulated and they said, now you got to earn your profits. And all of a sudden they said, where's Frank? Remember those ideas he has? Now we need to get more efficient. We got to do things better so that we can cut our costs so we can make money. So all of a sudden the opportunities were there for us because now the industry was ready to innovate in order to make their profits. And that was a big change for us. And that's where I got my opportunities because they go like, okay, remember you said you could automate the plants? So I went in, a team of people, we automated it, created plant processing, and then I would teach other people how to run it, and then I'd move on to gas purchases. Then I would go ahead and look at gas purchases. You can't develop something, and this is for IT and everybody. don't ever take on a project if you don't know the underlying business reason for doing it or the benefits of it intimately. Not that you heard it or you saw it in a presentation, that the technology is going to fail. If you don't understand the specific needs and what the objective of the project is to develop automation, I've seen billions of dollars spent and technology failed and they shut the projects down because they never knew what it was they were building. They just started building automation. And you don't build, you know, I think it's an old Chinese proverb, don't take the first step till you know where your destination is. Okay, so that holds true. So anyway, so what we did is I would go in, I would learn what purchase people did, how we negotiated with Pennzoil, how we bought it offshore, how it moved onshore, and we would develop systems. And then I moved on to transport, then to storage. So I developed a career of going from one department to another, learning it intimately, and then developing software that managed that. And if it weren't for that opportunity, I wouldn't be able to have developed the software that we'll be using, that many of the companies across the United States are using, because it touches every single part of the industry. From electronic interface, from online platforms where the traders buy billions of dollars, to transportation on pipeline systems, to invoicing, to accounting, financial results. And we'll see all of that in the next few weeks. Then after we spent some time trying to get out of deregulation, and we spent about 40 years, 20 years, I'm sorry, 40 years to where we are today, but 20 years here, developed a lot of things. We started DMS. And again, I had a professor, and here's another story. I had a professor that I learned from down in Brownsville when I was at Pan American University, now the University of Texas in Brownsville. And we were sitting in the cafeteria and I was just discussing with him in general. And he said, Frank, he said, in your lifetime, you're going to hear, and that's the knock of opportunity. He says, when you hear that knock, he says, no matter what you're doing, go for it. He says, because it could be the opening of a great future. And even if it's not and you fail, you can always go back to what you were doing before the knock. And I remembered that. So I'm having dinner, because one of my jobs with the pipelines was to go to our customers in the Midwest and Minnesota, Illinois, Wisconsin, and we would have customer meetings. And I was eating dinner with the folks from Northern Illinois Gas, NICOR, and a lady by the name of Rose Gorman said to me, Frank, you come up here and you say to us that you're going to develop invoices that we're going to get electronically, and that you're doing this and you're doing all these computer systems for the pipeline. She goes, and we're still on spreadsheets, and it's taking us, we're there till midnight, till 2, 3 in the morning, running processes, trying to figure out where our mistakes are and everything. He goes, you know, if you built a system that could capture our purchases, do our sales, transport our gas, and track it, we would buy it. And at that very instant, I remembered my professor and I heard. I came back to Houston. A year later, I opened DMS. I built a system in 1 year, went back to NICOR, and they've been my customer for 27 years. So what that professor told me, had I not heard that advice, I may not have heard the knock, and you and I may not be talking today, okay? So that's just, you know, and again, the opportunities are there if you keep your eyes open and you make your own opportunities. They present themselves, but you have to take advantage of them, okay? So we're going into this 90s, develop the software, going to this, and here's a brand new ball game. In the 2000s, a new technology called fracking came about, where we had always seen this belt of energy under the ground, and we have a slide coming up, so I won't get into it a lot, but we had this band of rock that we knew had a lot of gas and oil in it, but we didn't know how to get it out of that rock. The only thing we knew how to get out of were big containers, big reservoirs that had like a cup or a giant underground cavern, right? And we knew how to get it out of there because we put a pipe like a straw and suck it out. But how do you take, right? How do you take energy out of a rock? And that's what fracking is, and we'll talk about that. So that revolutionized our industry. What we're seeing today is a brand new marketplace, and we call it Hello World. And I do that on purpose because one of the first messages that was sent by technology from one person to another said Hello World. And we're saying Hello World to the world because we now can take all the abundant energy we have, we can liquefy it, and we can send it around the world, regasify it, and it's almost as if we were producing the gas in those countries. One of my customers, Washington Gas Midstream, sent me an email back in 2017, said, Frank, says, just wanted to give you an update. We just signed a contract with the largest gas provider in India to sell them several million units of gas every month for the next 25 years. So, you know, just want to give me a heads up. I got work till then, right? But anyway, so they're signing contracts. Shell signed a big contract with a lot of the foreign countries. So we are now shipping, and we got a brand new marketplace around the world. They're going to need more people to man all of those administrative, operational, and all the facilities to ship that gas around the world. So again, this whole chain of events, although it changed in the way it was operated, regulated, the energy that was coming into it, but these three things never changed: the acquisitions, logistics, and dispositions. Supply, demand. And logistics is processing, transport, and storage. This slide is extremely important, okay? Any questions, Amanda?
Yeah, we have a couple. The first one, what's the questions for the answer of supply, logistic, and demand?
What is the question?
Yes, it's what's the questions for the answer of supply, logistic, and demand?
What are the three natural gas industry fundamentals? These are the business fundamentals: supply, logistics, demand. And I would ask it, what are the natural gas business three fundamentals? Three moving parts, right? Okay.
We had one more. It was just a clarification of, does deregulation mean privatization?
No, it means non-government governance, right? Before the government was dictating, you know, how the price and how you sold it and everything. So if anything, it made it, and I hesitate to say privatization, but it made it a marketplace, because again, even privatization means it's owned, in my mind, it's owned by a private individual or group of individuals. In this case, it would be the stock market, say, for example, and it leaned more not on who owns it, but who regulates it, right? So they were regulated by the free market. Let me explain that. When the government regulates it, then that's who you have to please, the government. If you follow their rules, you will get paid what they say. When you're deregulated, okay, you work for your marketplace. So if you don't do a good job, they don't buy your product, okay? So who are you trying to please? The regulators or your market, okay? That's the difference between a regulated and a deregulated marketplace. Liquid natural gas, we talked about it a little bit. And if you keep your eyes open, right, you remember that knock I told you about? I read this a while back and I went like that. Before the liquid natural gas, we've always liquefied natural gas, but we liquefy it for the purpose of peak needs. And let me explain that. Sometimes when there's a high demand for gas and you can't ship it to where you need it quickly enough, you can give it a boost by injecting it with liquefied gas that increases the energy potency of the gas, and it spikes the energy. And that's really what you're burning. You're burning energy, not quantities, right? So the more energy is in those quantities, the longer the burn, right? So they have always done liquid natural gas for that purpose, as a injection into the stream to give you more potent energy. Well, they started now liquefying it, not for that purpose, but because you can take a tremendous amount. Gas is very voluminous, right? It takes a lot of space. So if we had to ship gas in its natural state, we would have to have a ship the size of Texas to ship it across the world, right? And that's, I'm just exaggerating, right? But it'd be huge, right? They wouldn't be able to make a ship big enough. So what they do is they take that voluminous gas, and they liquefy it, and then they can put it like in gallons, right? So they turn this voluminous gas into barrels or gallons of liquid, ship them through tankers around the world, and when they get there again to the other side, they degasify them or decompress them, and they regasify them. They make them into a gas again. And now you got the gas in another country. So when I saw that Shell had acquired a BG group and they bought, okay, $70 billion of tankers, and they weren't for oil, I immediately knew that you really should invest in liquefaction plants, because what is Shell going to do with all these ships? So you should have, people that were astute to the market should have seen back in 2015, they're going to start shipping gas around the world, or if not, Shell wouldn't be buying all these ships. Remember that knock, okay? Now here are all the liquid plants that convert gas. And the one right here, number 10, that's the one our customers use to ship gas to India from this right here. So it's an energy boom, major investment in these plants. There's the, I think it's Cheyenne, and there's a couple of them here in Galveston and Beaumont. There's several. You can see how they're all coupled in here. And there's a reason why they're here in this area. And again, I hate to say, we'll talk about that in a little bit, but really shortly, right? For the last 100 years, I'd say the last century, for the last 100 years, the people in this area right in here in the middle, the Midwest, the East Coast, needed energy because they consumed all the energy they had in their ground. So they had to ship it from the Gulf up for their needs. But when fracking came about, they got new energy over here, and they didn't need the energy from the Gulf. So it got bottled up because they didn't need it anymore, because they had their newfound energy from fracking, that now you had all this gas, and that's why they're making all these plants, to get all that bottled up gas out of the country. So several multi-decade contracts already in place around the world. Energy industry boom, shipping industry boom, and US employment in the energy sector boom, right? This is what fracking looks like at a very, you can go to YouTube and they have actual videos of fracking operations and so forth. Again, not getting into the weeds of the discussion of whether fracking was good or whether fracking was bad, right? Initially, in the early years, there was a lot of discussion. You saw YouTube videos of people turning their faucets and turning the faucet water would light up and so forth, and they disproved some of that. And those are just the people that didn't want fracking. They were afraid it was going to affect the water table. But as of yet, we haven't had, after close to a decade of really heavy duty fracking, we haven't had that occur yet. So we'll hope that that doesn't occur. And the way that they manage this is, very safely with a lot of precautions. They don't want to do that. I think sometimes people forget that the people in the industry of the natural gas, I was amazed that the people in the industry are your neighbors. They live where you live. They shop where you shop. Their kids go to the schools your kids go to. They don't want a pipeline exploding. They don't want to get dirty water for their kids. They don't want their food to be contaminated. So it's not true that the natural gas industry doesn't care. I was amazed when I first started the number of hours that I had to take on safety and precautions. And as we were developing systems and I went out in the fields, the way that they treated the safety factor, they would keep statistics of incidents on the field. They gave promotions and bonuses for having a safe work environment. So there are a lot of safety. Now, do periodic accidents happen? Absolutely. You go and find them. This pipeline exploded and all that. Well, that business needs to go out of business if they're not doing things right. And that's what the marketplace does to people that don't do their business right. But long story short, the shale gas that they're taking out of this rock, and I'll explain it here, is that they actually go in, and this dark area down in my screen here is the shell. And for many years they saw it, but they didn't know how to get it. So they fracture it. They literally have a small explosion here that fractures the rock. Then they put sand, the granules of sand, to block it from closing so that the gas and the oil seep out, and this pipe sucks it up like a vacuum cleaner. And this was done by the Mitchell boys out of Oklahoma, some engineers that worked like about 10 years to actually get that process in place. And we now have that. So here's another picture, and we'll go from frack gas to where it plays a part in the overall scheme of things, right? And you have different types of energy that are carbon-based, right? And let me explain that. So if you have gas right here, it's called conventional non-associated gas. And you need to study this because this is on your test. But non-associated gas, it doesn't like to associate. So there's nothing but gas in here. There's no oil in here. There's no other type of ingredient in here. There's pure gas, and it has byproducts, and I'll explain those, but there's not oil in there. Okay, so it's non-associated gas, no oil. Associated gas means that there's oil and gas. They're both. So they're associated gas. And when they bring it up, they have separators that separate the oil from the gas. So you have non-associated, immediately you know it's only gas. Associated, you know there's oil and gas. Okay, so now you have here coal beds. Okay. Coal beds used to be these reservoirs that got too close to the surface, and the sun dried them and made a liquid and gas into a solid. So really, this, and this are all the same thing, right? Coal is the same thing as oil and gas, except it rose to the top and it dried the liquid part of it. So now you have that black coal. It's dried oil, right? So now you have the seal that you have here that covers these back, right? You have tight sand gas. This is sand that's mixed with sand, gas that's mixed with sand. This is more expensive because it's harder to process because you got to separate it from the sand. Then you have limestone here, and that's just a bed of limestone where this is trapped. Now, this was easy to get because they are actual caverns or reservoirs that have locked in the energy. And all you do, you see like a straw, you put a pipe in and you bring the gas up and out. On the other hand, this is the same thing. You put a straw into it, which is a large pipe that's drilled down under the surface, and you bring the gas up. So now you got it to the surface. Now the trip begins to the marketplace, and we'll talk about that. When fracking came about, right, for oil and gas, like I said, they go ahead and they found out. If you can imagine, if you've ever had like bubble wrap in your Christmas gifts, I don't know how many of you, but I have a habit of liking to just sit there and pop the bubbles, the little plastic bubbles of bubble wrap. That's what fracking's like. Imagine in that bubble wrap, there's all this energy inside of it, right? So we just pop all the bubbles and all the energy comes out, and then we swoop it up and take it up to the top. That's what fracking is, right? No questions?
We have 2 questions.
Okay.
One, what's one of the biggest liquefaction companies?
You're going to put me on the spot. It begins with a C. We'll get back to them and put it on Blackboard. There's actually 4 big companies, but we'll get back to them on that one.
The next question is a student wanting to know your thoughts on the shutdown of the Keystone Pipeline and its effects on the market.
Whew, man, I wish you wouldn't have asked that question. Let me think here for a minute. Let's see here. On the Keystone, right, I'm going to go ahead and give you an answer on that. I want to show you a map from about President Obama's administration. They did not like the fact that there were going to be a pipe that might destroy the beautiful scenic landscape that's America, right? Because, man, who wants a pipe running under the ground? Until you look at this map. This is the interstate and interstate map of all the pipes already under the ground. How one more pipe coming here to here from here to here is going to affect this, I don't know. I don't think it is. There's a lot of jobs related to it, and the gas is going to eventually make itself to Houston to create jobs, so it's shipped out through vessels in here. So I think there's going to be lawsuits. One, because there was an agreement to allow the Canada to invest in bringing the pipe here. I think it's political, to be truthful with you. The person that right now it benefits from some of these are the people that transport the gas or the oil above ground, such as the Burlington, you know, the Santa Fe trails, the trains. They are shipping the gas already, or the oil already in tankers, right? So if the pipeline's completed, those companies lose that business. And I think those companies have a lot of influence in Washington. So why would you stop a pipeline that's already almost complete, right? That's going to bring economic benefit to the United States. I would rather move the gas through an underground pipe than see it moving on rail through the United States. So again, that's just my opinion. I think it's a bad decision. I think it's political. I think that at the end, I think we're going to suffer for not doing it. Okay. And that was my personal opinion. You know, it's not part of the university's opinion, because I'm sure they probably have a different opinion.
We have a few more questions.
Okay.
One being, isn't the pipeline running through a lot of Native American land that they're objecting to?
I think it already did. And my point was that it only affects it while the excavation is going. But I've seen the pipeline. I wish I could show. Let me see if I can bring something up real quick here. I wanted to show a picture, right, of a pipeline that's already buried in the ground, and you can't even tell it's there, really, you know. So once they bury it, then they cover it, the grass grows back, and they're good to go, right? So if it were going to be like an eyesore and you had to see it from your house or whatever, I would complain too. I just don't see, I guess, out of respect for the Indians, you know, and out of respect for their land, you can do that. But then again, there's eminent domain that, you know, the government can do things that benefit the masses over the individual rights. So, you know, you can go either way with that.
Would you say that the railroad industry lobbied against the pipelines?
I think just from the perspective that they're shipping it right now, yeah, they don't want to lose that revenue. I would say yes.
And last one, could you just define fracking again?
Fracking is the practice. Okay, let's go here. Fracking is the practice of fracturing the shell. You see this from here, from right here to right here is shell. It's a darker looking rock formation. And so shell is a rock formation. This is sandstone. This is sandstone. There's another bed right here, a different bed. So these are layers of earth, right? And this is a shell. This is hard. And in there are these little bubbles that contain energy, and we need to fracture them. And thus the word fracture became fracking. So you fracture the shell, stick little grains of salt, because if you fracture it, the weight will close it again. So they put little rock or little sand that keeps it open. And then the gas seeps out and the oil seeps out, and they bring it in here. You see this picture, inflow, right there? Sometimes they push water and they pushed it back out. That's another way they do it. But in that water is sand, okay? So the definition is fracturing the shell earth, right? The shell layer to extract the gas and oil. That good?
Yep.
So now that we know what our industry is about, right? We know that we got, let's go over here. We know that we took that easy example right here of actually saying it's very much like any other industry that has supply, and the demand's way over here, and the customers over here, and the producers over here. So he has to extract it from the ground, put it on a transport. You know, in this case, if it's wheat, then there's trucks. If it's gas, it's pipelines, but there's still transport. Processing is preparing the wheat into Wheaties or Frosted Flakes to make it ready for the market, and then they take it, or they store it in storage facilities, in warehouses. We store it in underground facilities until we need it, because you don't need it every day. You know, the one that goes directly is enough, but in the winter, you might need to draw some out when it's high demand. So we know that that's the way the industry works, right? And we covered, let's see, right in here, we covered that. So let me cover one last thing, and we'll go through this. In the market, or in the industry of natural gas, you have three marketplaces, okay? And what we saw here earlier, in this one here, where you have supply, transport, processing, storage demand, or supply, logistics demand, right? In here, supply, logistics, demand. In these three markets, which is the production market, the wholesale market, and the consumer market, you have those three things working. You have production, logistics, and demand. You have production, supply, logistics, and demand. In the last market, you have supply, logistics, and demand. So within the three markets, you have the three processes. Now, you don't always need all three. Sometimes the gas comes out and you transport it, process it, and deliver it. You didn't need storage. Sometimes you take it from, and the gas is so clean, you go around the process and you store it, or you go directly to demand. So they don't have to do all three. They can. Definitely, you're going to need at least supply, transport, and demand, right? So those two you normally need, or supply, transport, and storage, and any combination, and we'll talk about that. But what I wanted to show you in all three marketplaces, the production market, the wholesale market, and the consumption market, okay, you have those three: supply, logistics, demand, supply, logistics, demand, supply, logistics. So it's a chain with three markets and three streams. In the industry, it's called upstream. You know, immediately you're talking about the production area. The midstream is the wholesale area, and we'll talk about why they're different. And the downstream is the consumer market, okay? So there's three marketplace, three streams, and three processes. So we'll go over one real quick. Here, the producer produces it, maybe sells it, the buyer transports it, takes it to a processing plant, gets it processed. We'll have a whole week on processing plants. We'll have a week on supply vendors. We'll have a week on transport and so forth. So the demand comes here. They put it into the bigger market. The pipelines here are little pipes. They're like 1/2 inch. These are like 3, 2, 3, 4, 5, 6, 7 feet because they travel across the country and they move huge amounts of gas. Here they're gathering small amounts to aggregate them so that they can put them into the big marketplace to put it wholesale here. And eventually they hand it off to the distribution. And just like this says gathering, to where they gather small quantities into wholesale quantity sizes. And then the wholesale gives it to the distribution, and the distribution takes wholesale quantity sizes, large quantities, and they start breaking them out down into little distribution pieces so they can deliver it to your house or to your store or to your hospital. So you can't take one of these 5-foot pipes and connect it to your house. So we'll see how this all works. So from that perspective, you have the three marketplaces, the three streams, and the three processes. Now, within this, you have the front office, the middle office, and the back office. And over here, you have the three offices. And over here, you have the three offices. These offices will trade, schedule, transport, store. The middle office controls the transactions to make sure they're accurate. And the back office pays bills and invoices. So we'll cover all of that. In my career, I've met people, like we had a lady up in Omaha, Nebraska, when I was developing Northern Natural storage system. And all she did was she handled storages and got paid a lot of money just for doing just this one piece. And when I went to talk to her, you know, we couldn't start the meeting because she could be late and you had to wait, because without her, nobody knew how storage worked, because she was like the storage person. She knew how much injections and withdrawals and MDQs and injection fuel, withdrawal fuel, in place gas. You know, we're going to learn that. We're going to know what that lady knew. Okay. And we had to wait for her to come because nobody else could talk about it except her. They had to ask her. And she walks up with these 3 big giant binders, those 3-tab binders. And she pulls them out and she starts explaining it. And she looked at me and probably figured I didn't look very smart, but she was going to try anyway. And she explained to me what it is she did. And yeah, we built a system. And then everybody knew what it was, right? And everybody could use it and see how much gas they had. And she became even more powerful because it was her system. You know, she took ownership of that system. Embrace change, especially if it's good change, right? So that's what I'm saying. You could probably, if we learned this, you could get a job in the industry just doing this, or doing processing, or doing transport, or doing hub storage, right? So we're going throughout the course. I want to encourage you to attend the online sessions because you can get questions and answers. And this is the big, big, big picture of what it is that we'll be covering. And in each of these pieces throughout the course, you will know what occurs here firsthand from somebody that's designed the systems that all these people use to do their business across the United States, you know. So do we have any more questions?
We just have one. Does shale have oil and gas or just gas?
Oil and gas. Good question. Has both oil and gas. We'll look at this slide here. This is business management, okay? Because I want to get to, let's talk about this and then we'll go jump to that other slide. I'm jumping around a little bit just because it fits better for this course. You see here again, acquisition, logistics, disposition. In other words, for supply, demand, logistics, right? By the end of the course, you will jump up in the middle of the night saying acquisitions, logistics, and dispositions, okay? And that's a good thing because that means you will have understood it, right? The way that these systems are related, and I told you we'd look at the transactional, the flow, and the linkages, right? Acquisitions in this picture are down here. This is West Texas. This is the Louisiana Gulf Coast. This is like Amarillo, right? In this area on West Texas. And you notice here, this is the natural gas pipeline of America, NGPL, one of the largest companies that ship gas. We'll talk about several of them, but they pick up gas in West Texas and in Louisiana, and they ship it along these legs up to Chicago. So what's keeping Chicago warm and their lights on started in Louisiana and started in West Texas in the Amarillo area, right? Now you'll see here, this is called the G leg and the A leg. So you're in an interview or you're talking and you got hired by a marketing company, you say, yeah, we're gonna be shipping on NGPL. And you say, is that on the A leg or the G leg? They're gonna say, what? Right? How do you know that, right? So that's what applicable knowledge is, that you can use it in a discussion. We're just not briefly going over it. You're gonna learn this stuff and you'll be better for it. But here you go. So we get the supplies here. We have processing plants in this area. Why do we have processing plants down here? Because you don't wanna wait till you get up here to clean the gas. If you were giving somebody a ride in your brand new car and they had muddy boots, would you wait until they got out of your car to clean their boots or before they got in your car? Well, it's obvious, right? You want them to clean their boots before you get in your car. So you want them to clean the gas before, because the gas has dirt, sand, mud, oil. It's got all sorts of stuff in it. We'll go over that. So processing plants are here. Notice storages are over here. When you go to the store, do you buy your groceries and leave them outside of the store in a storage facility next to the store? Or do you put them in your pantry next to your kitchen, right? So that's why you put it here. You're gonna use it here. So why would you store it down here? You store it where your need is, okay? Just like you do your food, no different, right? So if they say, where are the predominant storage facilities? In the distribution area, right? Where's the processing plants? In the production area, right? Where are the gathering systems? In the production area. Where are the transmission mainline systems? In between the two. And where are the distribution systems? Where you're distributing them to the consumers in Chicago. So just from this one class now, you understand the different pieces we've been talking about, right? And why do you have this weird looking pipe that goes across, right? The reason why is I learned early on, if it's in the dead of winter and Chicago doesn't have gas, people will die because the winters are so harsh in Minnesota, and there's other pipes that go up to Madison, Wisconsin, A&R, other pipelines. So we knew that if we didn't do our job right and didn't keep the pipelines operational, people's lives were at risk. So we had to have a way to make sure. So what happens is if there was an explosion or a constraint on the G leg, there was a way to cross that gas over to the A leg to get it to the people in Chicago. If there was a constraint on the A leg, there was a way to cross over and get the gas to the people in Chicago. So there is a fundamental, just a standard look at what pipelines look like, and we'll put it in a map later. But review this, because this is the core of the class: acquisition supply, logistics, and disposition demand, right? Processing plants, very good definition here: making the gas market ready. Transport, moving gas from supply to demand. Storage, storing for peak demand needs, right? What is supply? It's the feedstock of the industry. That's what starts the flow. The gas is put into the system and the flow begins to go down this way. This disposition is the actual units of gas that are sold and consumed, okay? If I wanted to call the streams, I could put an arrow to this being the upstream. In the middle would be the midstream, and this would be the downstream. We could call this over here the production, the wholesale, the consumer market or distribution. Goes back and forth. What we're going to do, since it's the introductory class, we're going to stop right here. We'll leave it because once I get into regulated and non-regulated, there's quite a bit to cover. So we'll remember, Amanda and Mohammed, that at this point, the regulated, non-regulated is where we are going to start. Going back over real quick, don't forget the three major fundamentals. And one of them has three moving parts, which is the logistics. Remember the three parts of the system, the three markets of the system, the three pipes of the system, and the three processes of the system, right? The fundamentals. Remember associated, non-associated, shale gas, frac gas, where coal is, okay? Remember where the plants are and why we're building plants. Review, if you will, the history of how we went from no regulation to over-regulation to deregulation to fracking to the new world of shipping around the world. And with that, if we have any more questions, I'll answer them. Or if not, we'll go ahead and call it a day for today and meet again tomorrow. Not tomorrow, okay. Only I will be here. We'll meet again next Saturday. Amanda, any questions?
Not yet.
Professor, I have a question. Are you gonna be posting the lectures online?
Yes. We'll send you the link when they're available.
Thank you.
Did you miss part of it?
Yeah, I was distracted by my brother.
Oh my goodness, all right. Any other questions?
Someone is asking what fracking is again.
Okay, they must have come in late. All right, I don't mind. Fracking is one of several ways of getting the gas out of the ground. Let me see if we go right in here, right in here. You have what we call different ways of getting it, which is the traditional reservoirs, like associated, non-associated. Fracking is the way of getting the gas and oil out of rock. It's called shale rock. And it's using a way of bursting the bubbles in the shale rock and absorbing the gas and oil back up to the pipe. It's called horizontal drilling, a lateral borehole with multiple stage hydraulic fractures. And that shows you that in this picture right in here, how they fractured. That's why they call it fracking, because you're fracturing the rock. Okay, any more questions?
Is class mandatory?
No, it's not. You run the risk. This is the only risk you do run, that if the video doesn't work, then you'll be out of luck. We can't guarantee the video. Right now I see it's recording, but if the recording is damaged or it doesn't come through, then, you know, you're going to have friends. You got to buy somebody lunch or something to tell you what the class was about. Was that it?
I have a question, Professor.
Okay.
Okay. Good morning. First of all, my name is Zainab, and I have a question about attendance. So I know that you've said attendance is not necessary, but class is mandatory. And I was reading the syllabus, and it says participation points. So when you say attendance is not mandatory, but you will call on us in class.
No, it's not mandatory, right? But you either have to watch the video. You're responsible for either attending the online class or watching the video, okay?
Okay, but you won't call on us in class. That way, if we're not in class, we won't get the participation point.
No, we don't take points away, and I got to look and see where that is. Is that in the syllabus?
It was.
Then let me go ahead and look at that, because that's not applicable. That was when we were online, when we were in person.
Okay, that was my only concern. Thank you so much.
No problem. And we'll look at it, Amanda.
We have two more
All right.
questions. One student said, I understand that you are active in the industry and just wanted to see what your opinion on the large oil corporation and how they are going to take into this account into a more clean energy initiative. Example, electric, etc.
Well, you know, we'll discuss it more, but then again, you see, it's not the electric. I mean, electric, there is no electric tree or electric reservoir. Electricity is a byproduct of coal, oil, or gas. So we have to create electricity from one of the carbon right now. Not unless we could create enough wind power or water or different kind of corn feed or some kind of, let's see, where do we have it right in here? Let me show you right here. So if we could take some biomass or hydropower or any of these and create enough electricity, then we'd be okay. Right now, most electricity, the majority is created or is the result of burning natural gas. And I don't know if that person knew that, but electric is the result of burning oil or gas. So if you create more gas, more electric, you're just burning more gas or more oil until we get to another feedstock. You know, if we can get to where we grow enough biomass or we have enough hydro energy to generate more electricity. Right now, it's only a fraction of what we need. Okay. And what was the first part, Amanda, again?
It said that they understand that you are active in the industry and wanted to see what your opinion on the large oil corporations and how they are going to take into account a more clean energy initiative.
You know, I'm seeing a lot of the energy companies invest heavily. And I think that where the break is going to come in is in the technology. There's nothing today that can convert us. We can go ahead and make mandates and say, we want to do this, you know, but until the technology is there to actually allow us to create cleaner energy, I think we're stuck where we are. Now, a lot of the energy companies are investing big money, the oil and gas companies, in coming up with that newer technology, with a better way of creating electricity. I think they want to get there too. Remember that they don't go out of business just because they convert to another energy source, right? Or a feedstock, what I call feedstock, because somebody's got to get it. Somebody's got to develop it. Somebody's got to get it to you. Somebody's got to send you the bill. What unfortunately is going to happen is that you will still get an electric bill every month, regardless of what energy stock they use. Okay. Any more? You said you had a couple?
I
Do you have any homework due next week? Nope. All you have to do is review the PowerPoint that we have, and we'll probably put the next PowerPoint up there and you can review that. You don't have to do anything for the next class. I think that's it. And if we have some communication, okay, somebody raised their hand. Go ahead.
Good morning, Professor. I think your class lecture is very interesting. So you said we can just watch the lecture video right after you record it and post it.
Yes, you can watch it again even if you attended, right? And you can
Okay,
use
so
it, you can use
mhm.
it to study for your test as well.
Okay. So yeah, because sometimes I make note I'm a little slow. I will miss something. So I think that would be more helpful than just attending this live session.
Well, you say you're slow, but you're smart enough to know what you need to do, so that's good.
So yeah, like before you mentioned that we don't need to do anything other than review the lectures for until next week, right?
That's correct. And
Okay.
we probably go ahead and start getting some of the labs the week. We'll give you the passwords and everything. If not next week, the following week, and then you will have some lab homework. But it'll probably be the third meeting that we have.
Okay. Yeah, I don't think it will be too much.
No, not at all.
Yeah. Thank you, Professor, for the lecture.
Oh, you're welcome.
Mm-hmm.
Okay, Amanda, that's good.
Okay.
All right. Thank you, everybody. Have a good week, and we'll see you next week.
Thanks, Professor. It was interesting.
Thank you, sir.
sorry, it was
Have a great weekend, sir.
thank you. Have a great weekend. Thank you, Professor.
You're welcome.